let's understand the principles of the empirical rule. Now, when the data is symmetric and bell-shaped, that's when we can approximate data with standard deviation about the mean. So what we're saying is if we have a bell-shaped standard deviation curve, man, that thing looks real nice. The empirical rule says 68% of the data falls within 1 standard deviation of the mean, 95% is within 2, and 99.7 is within 3. So some people call this the 68, 95, 99.7 rule, which kind of makes sense because those are the 3 values. So what that means is if the mean is in the middle, and it is, right, then we know that 1 standard deviation to both sides, so the mean plus a standard deviation and the mean minus a standard deviation, well, this is 68% of the data. And this is all about being symmetric. So that means this is 34% and this is 34%. Well, then we go to 2 standard deviations away. So, wrong button. Mean plus 2 standard deviations and mean minus 2 standard deviations. So that means from here to here, right, the new one is 95%. And we already have 68% in the middle. So we have what? 27% left over. So that means 13.5% on this side, 13.5% on this side. Then we go one more step out, mean plus 3 standard deviation, mean minus 3 standard deviation, and this next one is 99.7%. We know that 95% is in the middle, so we have 2.35% here and 2.35% over here. Now you'll notice the whole thing is 100%. That means we have 0.3% not spoken for, which we call that the wings, right? So we have 0.15% in the left wing and 0.15% in the right wing. And this is the idea of the empirical rule, that if we're talking about data that lies on one of these 7 pieces, we can approximate the probability. Okay, so let's do one of these. In a recent turtle race, the slowest turtle averaged 2 inches per minute with a standard deviation of 0.85. Use the empirical rule to answer the following questions. Between what 2 speeds is 95% of the data, and what percent of speeds are between 1.15 and 4.45? Okay, so first things first, I'm going to draw myself a picture, all right, because I am very visual. And I know that my mean is 2, and my standard deviation is 0.85. Okay, so that means the mean is in the middle. That has a value of 2. Now, as I work my way to the right, I'm adding a standard deviation, right? So this is 2 plus 0.85, which is 2.0, oops, wrong button, 2.85. And then if I go another one out, I'm just adding 0.85 every time. So now I have 2.85 plus 0.85, which gives me 3.7. I also could have done 2 plus 2 times 0.85. It would give me the same thing, okay? And then if I go out again, I can take 3.7 and add another standard deviation, and that gives me 4.55. From before, we know our percents, 34, 13.5, 2.35%, and 0.15%. Those percentages are constant. For the empirical rule, they're always going to be that. Okay, now going to the left, we take our mean and we subtract our standard deviation. So that gives me 1.15. If I do it again, 1.15 minus 0.85, and I get 0.3. And if I go again, I'm going to get a negative value. And we're talking about speeds, so that really doesn't make much sense. So 34, 13.5, 2.35, and 0.15%. Okay, so now I can answer my questions, right? The first question says between 2 speeds is 95%. Well, we know that 95% is within 2 standard deviations. So if we go back to our picture and we say, okay, I want 2 standard deviations. So 2 standard deviations is over here on the right, it's 3.7. And if I go 2 standard, 1, 2, this is the one on the left, which is 0.3. So 95% would be 0.3 inches per minute, all the way up to, what did I just say, 3.7 inches per minute. Okay, hard to see that. 0.3 to 3.7. So that's letter A. Okay, letter B. What percent of speeds are between 1.15 and 4.55? Okay, let me get a new color. 1.15 and 4.45. Okay, so this is 1.15. So let me make that real thick. And the other one was 4.45. 4.55. So that's right here. So we're looking at all of these values in the middle. So 34, 34, 13.5, and 2.35. And I'm going to add those all together. So, whoop, wrong direction. So 34 plus 34 plus 13.5 plus 2.35 gives me 83.85% of data falls between 1.15 and 4.55. Now, you can see the empirical rule is great as long as you are right on those values. But what if you wanted to know between, let's say, 1 and 4? Well, 1 is about right here and 4 is about right here. I don't know what that is. So the empirical rule does have limitations because of where the values are. So just something to keep in mind.